All right. I'm doing some reading practice and research. I think we're looking at an NIST article. Uh, and I'm having some breakfast. I'm having cowboy burgers. Get fueled up, some protein to start the day. All right. So, NIST article, taking measure blog. Okay. Science-backed standards keep you safer in the skies. But if you've flown in recent years in the US, you're probably familiar with the airport security experience of entering a booth, raising your hands above your head, and having a machine check your body. That machine is called a millimeter wave scanner. A millimeter wave scanner. I know that machine. You stand up like that and does like boop, 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 boop. Scans for like metal and shit or x-rays. I don't know. Something like that. Scan stuff. I've done this many times and never given it much thought, but NIST researcher Jack Glover sure has. Sure has. Glover is a physics expert who works to make sure the Transportation Security Administration, or TSA, can test those machines effectively. Let's read more. That's not much of an article. Let's get to the whole article. This work has saved the government hundreds of millions of dollars and, more importantly, kept millions of passengers and flight crew members safe in the air. So, how do you keep those machines working properly? As with most things at NIST, it all comes back to measurement and standards. When you step into the airport scanner, the machine uses millimeter waves, see below, to capture an image of you. Millimeter waves transmit through clothing but reflect from skin, making them well suited to this task. An algorithm looks at each image and flags anything that is not a human body part for further screening by TSA agents. That's why you must take everything out of your pockets. There we go. What is a millimeter wave? Millimeter waves are electromagnetic waves just like visible light, radio waves, Wi-Fi signals, or even X-rays. They have wavelengths that are measured in millimeters or even up to an inch. This wavelength is much longer than that of visible light, but much shorter than that of Wi-Fi or radio waves. TSA needed an image quality standard to ensure that the scanners at every airport consistently delivered high-quality images to the algorithm. Glover explains that the process started by convening experts to discuss what characteristics of an image are most important for detecting threats. The group included experts from the U.S. Department of Homeland Security, or DHS, universities, equipment manufacturing companies, and other organizations. One of the challenges of this process is the variety of data that the millimeter wave scanner produces, including both 2D and 3D images. So the experts had to work toward a standard that rigorously tested all aspects of the multidimensional images. While there are many established test methods for X-rays, there was nothing for millimeter waves, Glover explains, so we applied our knowledge from X-ray physics to make completely new tests. The millimeter wave standard's impact. The TSA uses the standard called a technical performance standard in extensive lab testing and plans to test it directly in airports too. Glover explained that one of the standard's most important uses is testing new machines or parts that are swapped out in existing equipment. An example of this scenario would be if a supplier needs to swap out a part when a particular model of antenna is no longer available. This has happened more in recent years with various supply chain disruptions. The TSA won't just take the supplier's word that a new radar antenna works just as well as the old one. Experts have to check that new part themselves. Before this new standard was created, TSA explosives experts had to spend time and resource testing machines with real and simulated explosives in DHS's laboratories. These materials are dangerous and must be handled with extreme care. Now, the TSA can rely less on these tests by ensuring that the technical imaging performance has not changed, resulting in time and cost savings. Beyond the millimeter wave. This is just one of many joint projects NIST has worked on with the TSA and DHS's standards branch at the Science and Technology Directorate. For more than 20 years, NIST experts have used their deep knowledge of physics, measurement science, and standards to help keep people safe while traveling. With financial support from DHS, Glover and his colleagues have contributed to standards for systems that screen people, cargo, vehicles, luggage, and more. There's a photo here of NIST researcher Jack Glover's expertise in researcher Jack Glover's expertise in physics helps ensure that airport security machines are tested effectively, keeping people safe in the sky. Glover said he loves the research because of the ability to solve problems and help people. In this work, we are tasked to solve specific existing problems that stakeholders have highlighted, so we know those same stakeholders will use our research, he said. In this case of the security screening standards, I know they're being used because I get questions and comments almost every week from all over the world. Nice. I'm going to reward myself with some meat. Making progress. Sweet. Oh my God, that's so good. If you guys have never had them, dude, go to Sprouts, get a Cowboy Burger. Dude, they're these like big, thick patties, like that thick. And just filled with like spices and juicy goodness. Oh my God, that's so good. That's a good breakfast. Breakfast is 1:30. This is my breakfast for me. I don't usually eat when I first wake up. All right, traveling as a millimeter wave expert. After learning about Glover's work, I asked him about his typical travel experience, given that he devotes so much of his time to keeping us safer in the skies. While others may dread the security line, does he look forward to it? I like to observe what's happening. What machines are they using? What's scanning the bags? It's all fascinating because it's my work in action in the real world, he said. All right. Nice. A little bit shorter of an article than I thought, but about 5 to 10 minutes. Cool. Nice round number. Got another one. I'll do another video for the NASA one. All right. And this one, yeah, there you go. 7.5 minutes.